So this is the video presentation from the team Lospolloshermanos. The robots in our design are named Heisenberg and Jesse. This one is called Heisenberg. This one is called Jesse. They are employed at the site together, but they'll act individually at the time of disaster management. This robot that you see here is an amphibious robot which is inspired by Boston Dynamics Spot and the Velox robot. Though the mechanism is quite different than that of Velox, yet uh, this helical groove over here is used for water propulsion, and it is used by this robot to commute when it is placed inside the water. This robot that you see here, this is an aerial robot. Jessie is a rescue drone which is equipped with advanced technological features, and it includes a gripper mechanism. So this is how Heisenberg looks in SolidWorks assembly. So Heisenberg is basically, it is a robotic dog type body that has been set up along with a helical movable body in the lower part. This one is the helical movable body which will help the body to float and commute in the water surface. This robot, we believe, is capable of navigating its own route, collect information, and process it to the main station to report the scenario and damages of the landslide and disaster prone areas. This is equipped with few cameras. This is the thermal sensing camera. This is just a prototype. It was very hard to design actual thermal sensing camera. So using these technologies and also infrared sensor is kept over here. Using all of these in a combined way, it is, we believe, capable of navigating route and processing information on the site of disaster. Uh, with the help of strong processors like Raspberry Pi and equipped camera, we believe this is possible. It is also capable of doing computer vision tasks like object recognition and image recognition, which will be utilized to avoid the obstacles and even while reporting certain instances data. So it is equipped with two batteries, two lipo batteries, for we can call them lipo batteries for this moment. So one battery is responsible for controlling this terrestrial system, and one battery is responsible for controlling this aquatic propulsion system. I think this is going to help a lot when it comes to power save, because we are maximum optimizing the power by using two batteries and also not compromising on performance. This is the GPS sensor. It is also a prototype. Uh, so let's uh, know more about the mechanism, the locomotion mechanism. So this is the locomotion mechanism. So this way the robot will work. This is inspired from Boston Dynamics Spot, but it uses 4-bar mechanism and it uses servo to perform that. So there is two linkages of servo, and these two front legs, they are capable of moving this way as well, so that it will be easy to balance themselves in difficult terrains and also work on difficult path and also maintain and work in a different direction, in not only in straight direction but also in angular direction. So this is how they will work. This is applicable for all four legs. So this will be controlled by the servo motor. This is tilted with the help of this servo, and it will take help the robot to even go on different directional courses, like it can move at certain angles as well. So this is, we believe, is it is really helpful. Also about the uh, helical group propulsion system, uh, this will most probably rotate clockwise, and this will rotate anti-clockwise, and this will help the robot to move in a straight manner, and will tilt this to attain certain direction. So this is how the robot will perform inside water. So this way we can say that this robot is truly amphibious in nature. This robot is capable of transitioning seamlessly between land and water. On land, the servo-driven legs provide stability and movement, while in water, these helical groups activate to propel it through the water. This versatility will make it suitable for rescue operations, environmental monitoring, and exploration tasks, even in difficult terrains. So this second robot, its name is Jessie. It is inspired by the rescue drone that is used by the fire department in Oak Island, North Carolina. The video link to that drone is provided in the introduction section of this robot, in the PDF that we have uploaded. This is an aerial robot that is highly mobile, convenient, and fast when it comes to rescuing victims. This drone is equipped with modern technology. There are GPS sensors, there are strong microprocessors for data collection and retrieval system, and there is gripper mechanism as well. That is very useful and very handy for this robot. It can be actuated and it closes like this. It can work based on some pneumatic or motor driven system, which will be controlled by the control system of this drone. It will incorporate AI and machine learning to do a lot of work to identify the disaster site and to thoroughly investigate the desired site. So there is use of two cameras here actually. This is the thermal sensing camera, and this is the FPV camera. In this case we have employed Raspberry Pi camera, but in case we are doing something expensive, in case if we are building this in an expensive manner, we can import some expensive FPV cameras as well. So the thermal uh, sensing camera, it will continuously scan for heat signature, and and it will fetch the data to the microprocessor, which will send the further data to the main server, and which will eventually help the drone to locate people in need, especially useful in challenging environments where visibility is low. Also this camera is uh, very useful for a wide application of view, for a wide range of view. This gripper mechanism, it is, I think, the most useful case over here, because once the thermal sensing camera and the camera will identify someone in need, the uh, this can be used to employ some uh, maybe leave some medical supplies, or maybe help people uh, who are nearly drowning by throwing some tubes or swimming pads. So this is really helpful. So this is all about our robots. The measured design portion is made up of carbon fiber. This gripper is whereas made up of anodized aluminum, and a very strong rubber padding should be here in this gripper part. So this is all about our robot.